Hello, finance fans. Welcome back. This is part 2 of the lecture for Module 2, Time Value of Money. We left off last time calculating the future value of a 3-year ordinary annuity in which the payments are made at the end of each period. We're going to move on to the next one. I was going to have us do the actual equation, but instead of doing that, I'm going to do an example. This is a little bit different than what is in the notes that I posted. We're going to compare the future value that we did previously of the ordinary annuity, and now we're going to do the future value of an annuity due. So remember, the difference between the two annuities is that an ordinary annuity, the payment is due at the end of the period, whereas with an annuity due, it is due at the beginning of the period. So in this case, we have what is the future value of this annuity due, and we have the same terms as the last annuity. It is 3 years, $100 a year, 10% compounded annually. So the difference here is that instead of having my $100 at the end of each period, I'm going to have $100 at the beginning of each period. Now remember, it's only for 3 years. So I'm only going to have 3 $100 payments, and they're going to start at the beginning of each period. So I will have $100 at the beginning of year 1, okay? And my rate is 10% compounded annually, and this is an annual timeline, so my rate goes there. And again, we have 3 years, so the beginning of the first period, which is time period 0, or tick mark 0, and then the beginning of the second period, and the beginning of the third period. And that is our 3 years for our annuity due, because remember, the payment is due at the beginning of the period. Okay. Now we're going to calculate the future value for each payment period. So if we look, we notice that each of these tick marks is going to represent one of the periods, the compounding periods, right? Because we have it's compounded annually, and it's 3 years. So when I calculate the future value, I need to keep that in mind when I am calculating. So I need to determine how many periods in the future am I going to go. So for this first one here, I'm going to do the future value for this $100 that is being paid at the very end, or almost the end, okay? So again, when I calculate future value, I'm taking the present value, so 100, and then it is 1 plus the rate, which is 10%. And then my power is going to be how many compounding periods to go. How many are left? Since we are here at the second time period, we're going to go forward 1. So it's being compounded once. So then I have 100 times 1.10. And then when I do that, I get 110. Now we'll go in and do the same thing for this payment period. So information is very similar. So we have that $100, 1 plus the rate, the periodic rate, which is 10% since it's annual. And then our exponent is going to be how many compounding periods are we going to go forward. So in this case, we're here at 1. So we're going to go 1, 2. So that's 2 compounding periods, so our exponent is going to be 2. And we're going to get 121. And then we'll come down and do this $100. So again, I have my $100, 1 plus my rate. And now, how many compounding periods do I have to go? If we're starting here at 0 and we have to go all the way here to 3, it's going to be 1, 2, 3 compounding periods. So my exponent will be 3. When I do that, I get 133.10. Now to find out what my total future value is, I need to add up all of these values from each compounding period. So I'm going to take 110 plus 121 plus 133.10. And I get 364.10. So that is the future value of an annuity due. A 3-year annuity due at $100, 10% compounded annually, compared to my ordinary annuity, which is $331. So because it is being compounded more, we're seeing a larger amount at the end of the final period, right? Okay. We're going to skip this because we did both the annuity due and the ordinary annuity. So we're going to skip this example and move on to uneven cash flows. So to calculate uneven cash flows, we need to, there's 2 ways. We can do it by hand and calculate the present value of each cash flow, or we can use Excel, which you will see in the videos, as net present value. So we're going to do present value of this uneven cash flow stream. It looks like my rate is 10%, and I have 4 compounding periods, 1, 2, 3, 4, with my first payment or my first deposit at the end of the first period. So I'm going to calculate my present value the same as I would, except the same as I would with my future value with my periods, except I'm coming forward, right? So I'm coming, instead of going from 0 to 1 and counting that way, I'm coming backwards, right? Because this is a future value essentially, and I'm trying to find what the present value is, so I am discounting it by the rate. So I'm going to take my value, which is $100, divided by 1 plus my rate, which is the 10%. And my exponent is going to be how many compounding periods am I coming forward. So since I'm at 1 here, this is where my $100 is, I need to come back 1 compounding period, so my exponent is going to be 1. And I'm going to do that calculation. And I get $90.91. Okay, so I'm bringing it to the present value, to the present. Then I'm going to take my next one, which is my $300. So I take my 300, divide by 1 plus my rate, and my exponent is going to be how many compounding periods am I coming back. So I'm here at 2, I'm going to come back 1, 2 compounding periods. And when I do that calculation, I get 247. I'm going to round 93 cents. Then again, for my next period, I have $300, and this is period 3. So again, I'm going to do 300 divided by 1 times the rate, plus the rate, and my exponent will be how many compounding periods I'm coming back. So I'm starting at 3, and I'm going to go to 0. So 1, 2, 3. So my exponent is 3, and that's going to be equal to 225.39. Then we have our last payment amount, which is a negative value, and sometimes we will have negative cash flows in our problems, in our cash flows, and that is completely okay. So we're going to do negative 50 divided by 1 plus the interest rate, which is 10%. And again, my exponent is going to be how many payment periods we're going back. So 1, 2, 3, 4, compounding periods. So that's 4, an exponent of 4. So my present value of that negative 50 is negative 34.15. And in order to get our total present value, we need to add up all of these values right here. And when we do that, we get $530.08. Okay? The other option is Excel, which you will see using the net present value function. Now we're going to move on to the difference between nominal rates and periodic rates and how they're used. So a nominal rate is the rate that is usually stated in contracts and quoted by banks and brokers. So you would see this when you get in a savings account and they say that the rate is 5.5%, or you have a car loan and your rate is 4.49%. Okay, that's not really that's not the rate that's used in calculations or shown on timelines. We need to know the periodic rate for that. We use the periodic rate for the calculations. So if we're going to use a nominal rate, we need to be told how many periods per year it is being compounded. So for example, 8% is our nominal rate, and that's being compounded quarterly. In example 1. Example 2, we have an 8% rate that is being compounded daily. Okay, so these are examples of nominal rates. The calculations that we use the periodic rate. So we have to take our nominal rate divided by n, where n is the number of compounding periods per year. So for example, if we have something that's being compounded quarterly, we will take our rate and divide it by 4 if it's a quarterly compound. If it's a monthly compound, we would divide our rate by 12. Daily compounding would be 360 or 365. and so on and so forth. Monthly would be 12, just like this says. Semi-annually is 2. Okay, so for example, an 8% quarterly nominal rate, the periodic rate right here would be the 8% divided by 4, which is 2%. So my periodic rate, or my I per, is going to be 2%. An 8% daily, to turn that into our periodic rate, we take our 8%, divide by 365, and then we get our periodic rate, which is 0.021918%. So again, when we do our calculations, when we do our timelines, when we do our rate calculations in Excel, we want to use the periodic rate. Okay, so what is the rate per period? And that is dependent on how often it is being compounded in a year. What we want to do now is calculate the effective annual rate, or the APY, which is sometimes different than the rate that you're given, or the APR. When we have rates that are compounded more than once a year, overall, the rate is usually higher than the annual rate. So if we have something that's being compounded more than once a year, our actual rate, or our effective annual rate, will be higher than the given rate, or the nominal rate. So an example of that, so if we were to invest $1 for 1 year at 12%, compounded semi-annually. So we're going to calculate how much we're actually getting as a rate. Because remember, this rate of 12%, it's being compounded twice in a year. So it's earning 12% over 6 months. That money gets deposited back into the account, and then we start earning 12% on whatever is in there now. So our effective annual rate, what we're actually getting from interest, is going to be greater than our 12% here. So we have a present value of $1. Our interest rate is 12%. So I'm going to put that in a decimal form. I have the number of compounding periods is 2, because it's semi-annually, right? And it's twice a year. My time frame is 1 year, so we have to find the future value. Now we can do this in Excel, and it will absolutely give you the answer. But I want to show you mathematically how it's done. So what we do is we take, so the EAR is equal to 1 plus our rate, so whatever our nominal rate is, divided by the number of compounding periods to the power of the number of compounding periods minus 1. And that's how we find our effective annual rate, or EFF, or it's also called APY. So effective annual rate, effective rate, APY. So how does this look when we do it? And how is it different depending on how it's compounded? So on this next page, we can see we have a 12% nominal rate. What is the effective rate when it's being compounded? So if it's being compounded annually, we have just our regular rate of 12%. If our account is being compounded semi-annually, which means it's being compounded twice a year, our effective rate is 12.36%. If my compounding is quarterly, which means it's 4 times a year, my effective rate is 12.55%. Monthly, 12 compounding periods, so my rate is 12.68%. Daily, using 365 days, that's how many compounding periods they are, with an effective annual rate of 12.75%. So what do we notice about the relationship between the number of compounding periods and the effective annual rate? Well, as we increase in the number of compounding periods, what's happening to our effective rate? It's increasing. So the more often we're compounding in a year, the more money we're making, or the more money is, the rate is actually a little bit higher, making more off of that money. So the more often we compound, the greater the effective rate. Okay, so the only time the nominal rate will be equal to the periodic rate is if we have an annual compounding period, right? Otherwise, if we're compounding more than once a year, our EAR, or our effective rate, will be greater than our nominal rate. Okay, if our compounding periods is greater than once a year. Okay, so if we have a compounding, if we're compounding more than once a year, then our effective rate will be greater than our nominal rate. So when should we use effective rates? We want to calculate our effective rates when we're comparing investments which have different compounding periods. So for example, if we had an account that was 3% compounded quarterly and another account that was 2.85% compounded monthly, which one is actually going to be better for us? If it's an investment, we want a higher rate. If it's a loan, we want a lower rate, right? We want to figure out what our actual effective rate is. What is it that we're actually getting? What's the rate that we're actually getting? Another time to use effective rates is when the payment periods of the investment, or the it does not match the interest rate compounding period. So for example, you have a payment due monthly, but your interest is compounded quarterly. So again, we're going to use effective rates when we're comparing investments that have different compounding periods, or when we have payment periods that do not match the interest rate compounding period. So again, the difference between the nominal rate and the period rate, or the periodic rate, nominal versus period. The nominal rate is the rate that is written in contracts, quoted by brokers and banks, but it is not used in calculations, not used on timelines. We only use the periodic rates, right? Periodic rates is what's used in calculation and on timelines. To calculate our periodic rate, we take our nominal rate and divide it by the number of compounding periods per year. If we are compounding annually, then our periodic rate is our nominal rate divided by 1. So our periodic rate will be equal to our nominal rate only if we have annual compounding. Otherwise, our periodic rate will be different, because we're dividing it by the number of compounding periods. So let's look at this example. Bank A charges 10% compounded monthly on its business loans. Bank B charges 10.5% compounded annually on its business loans. Which bank would you choose? So now we're taking out a loan, so we want to keep that in mind when we choose which bank we're going to go with. So for Bank A, I'm going to calculate my effective rate. Okay, because the best way to compare banks that compound differently is to find the effective rate, because then they're in the same arena here. So for Bank A, I'm going to use the formula that we used earlier. So I have that, I'm going to use the 1 plus the 10%, 0.10, divided by the number of compounding periods per year. In this case, it's monthly. And my exponent is going to be the number of compounding periods, which again is monthly, so that's 12. And then I subtract 1 from that at the end. When I do that, I end up with 10.47%. And that is my effective rate. So this is what I am really paying, 10.47%. Now I want to compare that to Bank B. So Bank B charges 10.5% compounded annually. Now if we have a compound that is annual, that means that our effective rate will be the same as our nominal rate. So in this case, my effective rate for Bank B is equal to 10.5%. Okay, so if we look at these a little, if we compare, Bank A has an effective rate of 10.47%, and Bank B is 10.5%. This is what we would be paying in interest on our loan. Since it's a loan and it's money that we're paying out, we want to pick the bank that has the least expensive rate or the lower rate. So we're going to choose Bank A because the effective rate is lower. Okay, so if we're comparing loans, investments, anything like that, with rates that are compounded differently, we want to find the effective rate to be able to compare them. So let's look at this example. We have problem number 7. What's the value at the end of year 3 of the following cash flow stream if the nominal interest rate is 10%, compounded semi-annually? Okay, so if we look at our timeline, we can see that this is a semi-annual timeline. Okay, there are 6 compounding periods, and our periodic rate is 5%. Well, how did we get that? We have a nominal interest rate of 10%, and it is compounded semi-annually. So we take that 10%, divide that by 2, because it's being compounded twice a year. So each compounding period is 5%. So that's where this 5% comes from. Now we're compounding semi-annually, but our cash flow is annual. Okay, so how can we do this? There's 2 different ways that we can calculate this. So the first way is to compound each cash flow. So we can do the future value calculate the future value of each cash flow and add that up the way that we did previously in some other examples. So the future value of this $100 in period 6 will stay as $100. To calculate the future value of the $100 at period 4, we're going to take that $100, multiply it by 1 plus the periodic rate, and we know our periodic rate is 5%. It's the 10% divided by 2. So 1.05, and our exponent is going to be the number of compounding periods left to go. So if we're going forward, because we want the future value, so we're going to the right, we're going forward, we're starting here at 4. How many compounding periods do we have? We have 1, 2. So my exponent will be 2. So my future value of that $100 is 110.25 cents. Now we'll do the same thing for this cash flow in period 2. We have $100, 1 plus the interest rate, and my exponent is going to be the number of compounding periods left to go. So if I'm here, 1, 2, 3, 4 compounding periods. And when I do that, I get 121.55, and I want to add these 3 values to get my total future value, which is $331.80. Okay, so I took each cash flow and compounded each cash flow individually and then added them up. The other option is to find the effective rate and sketch a new timeline. So you can see here, I've already done it down here below, but let's do some calculations. So we have 10%, we know this is 10%, right? Because this is semi-annual. If this is the periodic rate, so that's 5%. Semi-annually, so annually would be 10%. So I have a 10% rate that's being compounded semi-annually. So I want to find my effective rate. When I do that, I'm going to get 1 plus the 10% divided by the number of compounding periods to the power of 2, because that's the number of compounding periods, minus 1. I get 1.05 to the power of 2 minus 1, which is equal to 1.1025 minus 1, which is equal to 0.1025. And I want a rate, multiply that by 100, and my effective rate is equal to 10.25%. So instead of having to compound each each payment period separately, like we did previously, I can now just use my effective rate to calculate my future value of this 10.25%. This would be, since we have a consistent payments over time, and this is now an annual rate, we can use the annuity function in Excel to calculate the future value of that. But remember, we can only do the annuity if our payments are the same, the exact same. Okay, if this were an uneven cash flow, if we had different cash flows, different amounts, we could not use the annuity function. We would need to calculate each cash flow separately, or use the net present value function in Excel. I'm sorry, not for future value, only for present value. Okay, the last part here is amortization. Amortization is basically the schedule of payments that you make or that you receive, kind of like a car loan. So if you take out a car loan, you'll see how much you pay every month. Some of it goes to principal and some of it goes to interest. So what we're going to do is we're going to make an amortization schedule. Now to do this, you need to use Excel to find first the payment value. So we have an amortization schedule here for a $1,000 loan. The rate is 10% annually, and we have 3 equal payments. So this is a timeline that represents the amortization schedule. So we're taking out $100, and we need to find out how much each payment is going to be. And then we need to find out how much of that payment is interest and how much of that is repayment of the principal. So the first step here is to find the required payments, and to do that you need to use Excel. The function for Excel is PMT. So PMT, and then you put in the rate, so you put in 0.10 because it's an annual rate and it's 10%, so you do the decimal, so 0.10. The number of periods, and per is going to be 3 because we're doing 3 equal payments. And the present value is the value of the loan, which is $1,000. And again, this is done in Excel, and it will give you a payment value. When you do that, you're going to get a value of payment of $402.11. So this is the payment, the 3 equal payments of $402.11. That's how much your payment is going to be. Now we need to figure out how much is going to be principal and how much is going to be interest. So step 1, find the required payment amount. Done. $402.11. Next step, find the interest charge for year 1. So to find the interest, we take the beginning balance of the principal times the interest rate, which is 10%, and we get $100. So our interest charge for our first payment is $100. How much of that goes towards how much of our payment then goes towards principal? So we take our original payment amount, which is $402.11, which we found on the previous slide. We subtract the interest charge that we just calculated above, and we have a principal payment of $302.11. So then we need to find the ending balance after year 1. So our ending balance, we want to make sure we calculate it correctly. We don't want to subtract the interest that we're paying because that does not affect our principal balance. Our principal balance is only affected by what we pay back in our repayment. So the beginning balance of our loan was $100. Our payment is $402.11. But if you remember, 100 of that went to interest. So we're repaying $302.11 of our principal. So this is your beginning loan balance. We're subtracting how much is being paid towards principal. This is your new balance for the next year or the next period. And then we continue this for the next period to find out the next payment. So if we look here, we have a chart. These are, that is not what I wanted to do. I apologize. How did that happen? Sorry. Here we go. Here we are. Okay. So we have a beginning balance. This was our principal balance. We took out $1,000. We calculated that our payment every period would be $402.11. Our interest payment is 10% of the beginning balance, right? It's the rate of beginning balance. So our payment was $402.11. We subtract how much goes towards interest. So we're paying $302.11 towards our principal. So the ending balance of our principal, so the ending balance is that $1,000 minus the $302.11. So we have $697.89 left. That's the ending balance of year one. So it's going to be the beginning balance of year two. And again, our payment is the same. Our payment has not changed. Our payment is the same for every single payment period. What's going to be different is how much we pay towards interest and how much we pay towards principal. So again, to find my interest payment, I take the 10% and multiply it by our beginning balance. When I do that, I get 69.79 rounding. So if I am paying $402.11 and $69.79 of that is going towards interest, how much is going to be going towards my principal? So I'm going to take the 402, subtract the 69.79, and I'm going to get 332.32-ish. So then this is how much is going towards principal. So I'm going to take this beginning balance, subtract what I'm paying towards principal, and that will be my ending balance. And that's going to be $365.57-ish. Will be rounding is a little bit off. So then this ending balance becomes our new beginning balance. Again, our payment stays the same. It looks like it shouldn't because your beginning balance is less, but remember, we're still being charged interest on that amount. So we still have to pay this 402 because 10% of our, we're going to pay 10% of our beginning balance in interest. So that 10% is going to be 56-ish, rounding. Oh, sorry. That is not correct. 36.56. So I'm going to subtract this interest payment from my total payment to find out how much I'm repaying on I'm putting towards principal. When I do that, I get about $365.55 with about 2 cents left. So this is going to vary because of rounding. But this is how we get our amortization schedule. This is our beginning balance of $1,000 loan. We calculated how much our payment would be, and that is consistent. Every single payment period, same payment amount. The interest that we pay is 10% based on our beginning balance. How much goes towards principal of our payment depends on how much we're paying in interest. So we take our payment amount minus the interest, and that is how much we're repaying in principal. To find out our ending balance, we take our beginning balance and we subtract the payment, the repayment for principal, and then we get our ending balance. And then the beginning balance of our next period is the ending balance of our previous period. And if you look at this next slide, it fills in all of the rest of those values for you. And here we have 2 cents left over. And this is just rounding errors. But again, you can see we have our beginning balance. Our payments are the same every payment period. Our interest that we pay is based on the beginning balance of every period. So we pay it down until we get to almost 0. And that is the end of this lecture. Please go into Canvas and review the videos on how to do this in Excel. We will have a problem set in class. You will need to use Excel, so please keep that in mind when you are watching the videos. Email me with any questions. Otherwise, I will see you in class on Tuesday, and there will be a quiz in Canvas for you to complete based on this lecture, and that is due Tuesday at noon, so don't forget about that. Thanks, folks.